Hello students, welcome to the channel of Parallax tutorial. My name is Pallabi and this is our 8th video on the series of topic-wise past paper questions of IB AAHL Mathematics Paper 1. We are covering the topic of functions. This video mainly explains logarithmic function in detail, how to graph them, find their inverses, etc. You may click on the link given in the description to access my previous videos where I have explained the concept of inverse of a function and plotting their graphs in detail. In this question, in the first part, we have to sketch the graph of y is equal to f inverse of x. Now, here is the tough part. For f inverse of x, the f of x function is not given to us, as in the algebraic function is not given. Instead, we are given a graph. So how do we make the graph of f inverse of x? So what do? What I do is I start with x is equal to y line. The reason why I do this is we know that inverse functions reflect along the x is equal to y is equal to x line, right? So this is my y is equal to x line. You may choose not to draw this line, but it helps understand us, how inverse work. So we know that y is equal to f inverse of x. This is what we have to plot. The given function has at x is equal to 4, the function's value is 0. So for inverse, at x is equal to 0, the inverse function's value would be 4. So we clearly have the first point, which would be 4. Next we look at the asymptotes. Now we have a vertical asymptote at x is equal to 1 for the given function, which means the function has a vertical asymptote at x is equal to 1, which means inverse function will have a horizontal asymptote at y is equal to 1, which means this is our horizontal asymptote. Now, why is this the case? Because remember, in inverse functions, what happens? The x and the y, they swap, right? Okay. Keeping this in mind, all we need to do is now sketch the function. Now, here comes the y is equal to x line's relevance. Because this black function is our f of x, the inverse function would be reflected along this line. So it will not reach the asymptote. Are we given a range here? No. So it will not reach the asymptote and it will cross this and it will go away and away, just like your f of x function is going away and away. And this is how the f inverse of x would look when we sketch it. And you get your 2 marks here. Question number 2, that is B part. State the range of f inverse of x. So we know that f inverse of x cannot be equal to 1 or less than it, right? So the range of the f inverse of x would be 1 to infinity. It's an increasing function like we see all the way up to infinity. We keep the brackets as open brackets or simple brackets, which means that 1 is not part of the range. Infinity is also not part of the range. You can also write it like this. Third part. Given that f of x, now they have given you the function itself. It is ln ax plus b. And x is greater than 1. That's the condition which is given. We have to find the values of a and b. To do this, let's first erase all the unnecessary parts which we don't know so that we get some clarity on how we have to work on this. Second thing is we need to know how the logarithmic functions, their basic shape looks like. So I'm going to draw a logarithmic function on the side and we'll very quickly go over the basic shape. This you should know before, when you do paper 1. So this is the shape of logarithmic functions, ln x in this case. At x is equal to 1, the function is 0. And as you approach 0, the ln function is not defined, which means when your x is 1, ln of 1 is 0. And when you do ln of 0, it is not defined. Knowing this, let's come back to the question which is given to us. We are not given a straightforward ln x question. It is a transformed function ln ax plus b, right? And the point 4, 0, which means f of x is 0 when x is 4, which means 4a plus b. Now, when is a function 0? When ln is 1, right? When x is 1, then the function is 0, which means 4a plus b should be equal to 1. This is our first equation. It will be a simultaneous equation because we have two unknowns, a and b, right? Second very important point over here is the asymptote, which is x is equal to 1, which means the function, this particular function is not defined when x is equal to 1. When x is equal to 1, the function is not defined. When is a function not defined? When ln of 0 is not defined, right? Which means ln of ax plus b will be not defined when ax plus b is actually 0, right? And that happens when x is 1 because that's the asymptote. So at x is equal to 1, ln of ax plus b is not defined. What does that mean? It means that ax plus b is 0 or a plus b is 0, putting the value of x as 1. So a plus b is 0, which means a is equal to minus b. This is our second equation. Let's put this value by substitution into the first one. What do we get? 4a, actually in place of a we can put minus b, right? So minus b minus 4b plus b is 1, which is minus 3b is 1. So b is equal to minus 1 by 3. And therefore, we know that a is minus b. So a would be 1 by 3. And that's all. Those are our values for a and b. There you go. Hope you understood this. Thank you.